Let's look at the pink part first, because I'm guessing most of you didn't do this blue part, and I'll explain that in a minute. So we take the derivative, we get 1 minus secant squared. So at first look, no fractions to worry about. So we just go ahead and set that whole thing equal to 0. And we get secant squared equals 1. Take the square root, we get secant equals positive or negative 1. And secant is the reciprocal of cosine. So cosine would have to be equal to positive or negative 1 also, since the reciprocal of 1 is 1. So we want to figure out when is the cosine positive or negative 1. That happens when x is 0, pi, 2 pi, all those coterminal angles. So we get x equals pi m. So we want to check those. If we do tangent of 0, or tangent of pi, or tangent of 2 pi, for all of those, sine over cosine, we're going to get 0. Right? That's okay. We can have 0 there. So that works. That fits into our domain of f. Now, this part, like I said earlier, it looks like no fractions, right? So we don't have to worry about setting denominators equal to 0, but actually there is, because secant squared is the same as 1 over cosine squared. So we have to think of, okay, what's going to make cosine squared equal to 0? Because anything that makes cosine squared equal to 0 is going to make this derivative undefined, make it not exist. So if we set cosine squared equal to 0 and solve, we get cosine is 0. And that happens at pi over 2, 3 pi over 2, and all those coterminal angles. But we want to check that. If we put pi over 2 in here, tangent of pi over 2, sine over cosine, we're going to get 1 over 0. So that doesn't work. It's undefined. Or if we do tangent of 3 pi over 2, we get negative 1 over 0. So it's undefined. So if you didn't do this, in this case you lucked out, because it didn't affect you, because it didn't give you any critical values. But you need to kind of keep that in mind when doing future problems.